All right, so this is some examples for section 2.5 dealing with implicit differentiation. And the first one I just made up because in the last video I actually worked out example number 5. So all right, so the first thing I need to do is differentiate both sides with respect to x. So I do d dx to both sides. And then I apply the operator to each term. And the 4 is a constant, so I could sort of put the constant in front of the operator. So I could write it as 4 times d dx and then y squared. Right, because that's one of our rules with derivatives. You can pull out the constant in front and then apply the derivative operator on the expression that's left over after you factor out the number in front. Derivative of 16 is 0 because that's a constant. All right, so when I find these derivatives, I'm going to apply the power rule. So derivative of x squared by power rule is 2x. And then I have plus 4, and then I'll put in parentheses. When I take the derivative of y squared, it's the same thing as if it were x squared. It's just 2 times y. And in the last video, I mentioned that each time I take the derivative of some expression and it consists of the variable y, I'm going to attach y prime with that. And again, so y prime is the same as dy dx. All right, so I have 2x plus 8y, y prime equal to 0. And the goal is to get y prime by itself. We need to solve for y prime. So I'm going to bring any terms that do not have y prime over to the right side. So I would subtract 2x. Then I have 8y, y prime equal to negative 2x. Now, if I want y prime by itself, I need to get rid of the 8y. So I divide both sides by 8y. Then I have y prime equal to, and then you reduce negative 2/8, so it'll be negative x over 4y. And that's it. That's going to be our answer. All right, so just to recap, we're doing implicit differentiation. The first step you do is you take the derivative, differentiate both sides with respect to x. So that's why I have the operator d dx on both sides. For the left side, I applied the derivative operator to each term. So that's why it says d dx with x squared. And then for the 4y squared, I just brought the 4 in front of the operator since it's a constant. So I have 4 and then d dx of y squared and then equal to 0 because derivative of 16 is 0 since it's a constant. So I apply the power rule, and the power rule for x squared, you drop down the exponent, so it would be 2 times x to the 2 minus 1, which is 2x, and then plus 4 times, and then in parentheses is when I apply the derivative of y squared. And that's the same sort of rule as the power rule, 2 times y, And then the only added thing here is that I'm attaching a y prime. And again, I only attach the y prime to any terms that consist of the variable y. All right, so then I did 4 times 2 to get 8, so I have 8y prime. And then I need to solve for y prime, get y prime by itself. So I'd subtract 2x from both sides and then divide by 8y. That way y prime is by itself on the left side and it's equal to negative x over 4y. Right, so that is the answer to that question. Now this next one is a question from the textbook. So it's number 9. It's supposed to be x cubed. All right, so taking the derivative, I differentiate both sides with respect to x. All right, and I just attach the operator to each term. And the derivative of 7 is 0 since that's a constant. All right, and I forgot the brackets. I mean, the brackets aren't completely necessary. It just kind of leaves it less ambiguous if you put the brackets. Now, derivative of x cubed, applying the power rule, that'll be 3x to the 3 minus 1. But 3 minus 1 is 2, so this is 3x squared. And I'll talk about in a second, I'm going to leave the middle. That's how you see it. And I'll talk about that in a second. Now the derivative of y squared, you apply the power rule. So you drop down the exponent 2. So it'll be 2 times y to the 2 minus 1, which is just 2y. Since it has the variable y, I'm going to attach a y prime. And then that equals 0. Now this is the part people might mess up on, is finding this derivative of negative xy. And what you're going to have to do is use the power rule. So I'm going to pause the video and write the power rule. All right, so I've written the power rule. I'm going to focus on applying the power rule to the negative xy. I'm using the power rule because it's negative x times y. It's a product, or sorry, not power rule, product rule. I've been using the power rule for the other stuff. So it's product rule, negative x times y, that's a product. So the product rule is u prime times v plus uv prime. And so I try to color coordinate it. U in this case is going to be negative x, and then v is y. So it's going to equal u prime times v. Well, if u is x, the derivative of negative x is going to be negative 1. So it'd be negative 1. So that's derivative of x, that's u prime, times v. Well, v is just y, so it'd be negative 1 times y plus u times v prime. U is negative x. V prime, well, the derivative of y is 1, so it'll be 1. But then since this involves a derivative with y, I attach a y prime. So this will be my v prime portion. right, so again, the derivative of y is 1, just like how the derivative of x is 1, but here we had -1 since it had the minus sign. And then since I find the derivative and it was involving the variable y, that's why I put a y prime next to the 1. All right, so this is equal to -y and then minus xy prime. All right, so that's what all of that's equal to. And all of this is the derivative of just that middle piece. So I'm going to write the problem down. So we have 3x squared. And then instead of the middle term where it was d dx of -xy, that turned into -y minus xy prime. So that would be minus, and I'll color coordinate it. All right, that was the derivative for the middle term. And then I have plus 2y y prime. All right, so the idea is to collect all of the y prime terms together and put all the other terms on the other side. Now the only y prime terms I have, so I have the -xy y prime and the 2y y prime. What are not y prime terms are 3x squared and minus y. So I need to bring these over to the right side. So to get 3x squared, I would subtract 3x squared. To get rid of the y, I would add y. All right, so that way these go away. And I'm left with the y prime terms on the right side. So I need to do 3x squared and then plus y. All right, so I have -x y prime and then plus 2y y prime. And then all of that's equal to -3x squared plus y. All right, so if I want to solve for y prime, I need to factor out a y prime from both of these terms. So I'd factor out y prime. That makes this first one -x, and then the second one plus 2y. And I need y prime by itself, so I would divide both sides by the -x plus 2y. Those cancel out, so y prime equal to -3x squared plus y divided by -x plus 2y. And that's going to be my answer. All right, so to recap, so this was the original problem. I differentiated both sides with respect to x, and then I applied the operator to each term. So that's why it says d dx, and then x cubed, d dx, -xy, d dx, and then y squared. Derivative of 7 is 0 because that's a constant. And then for x cubed, I applied the power rule. That turns into 3x squared. For the y squared, I also applied the power rule. That would just be 2y, but then since I'm taking a derivative of some expression and it involves the variable y that I'm taking the derivative, I attach the y prime with that. So then I focused on the middle term, -xy, because that I had to use the product rule since it's -x times y. And so I wrote down the product rule and tried to color coordinate that. We use purple for u and orange for v. So it would be u prime times v. Well, u is -x derivative of negative x is negative 1. So that's why it has u prime is negative 1. And then v is just y, so that's v. And then u times v prime, well, u is negative x. And then v prime is the derivative of y. Well, the derivative of y since is 1. But since I have taken the derivative and involving y, I attach the y prime. So that's why it'd be 1 times y prime. All right, then I just simplified it. So it's negative y, then minus x y prime. All right, that's what the middle term is when I found its derivative. So I just rewrote the problem and just put what's in red is what I found for the derivative of the middle portion. All right, then the goal is to get y prime by itself. So I put any terms that did not have y prime over to the right side. And that was 3x squared minus y. So I subtracted 3x squared and then plus y. That got rid of those. Then I had negative xy prime plus 2yy prime, and then equal to the negative 3x squared plus y. So now I factored out a y prime. So that gave me y prime times negative x plus 2y. And then I wanted y prime by itself, so then I divided by the negative x plus 2y factor. So that gave me negative 3x squared plus y over negative x plus 2y is equal to y prime. And that's going to be the derivative. All right, so that was that problem. This next one involves trigonometry. All right, so I'm taking the derivative with respect to x to both sides. Let me first write some derivative rules. So recall if I have a derivative of sine of u, where u is a function of x, that turns into cosine of u times u prime. If I have the derivative of cosine, all right, this is chain rule from the last section. Derivative of cosine is negative sine, the negative sine of u times u prime. All right, the inside function, right, outside function is the trig function cosine or sine. Inside function is u, where in the other one's outside function is cosine, inside function is u. All right, so that's chain rule, and this was covered in the last section. So for this, take the derivative both sides. And I'm going to attach the operator to each term on the left side. Because there's a 2 in front of the cosine of 2y, I'm going to factor out the 2 in front of the operator. So it'll be 2 times and then d dx. And then cosine 2y. And then derivative of 1 is 0 since that's a constant. All right, so first thing is sine of x. Derivative of sine is cosine. And don't necessarily need to apply the chain rule for this term because it's just the inside function is x. So u prime would be just times 1. So it's just cosine x. Now for the second thing, if I d dx of cosine of 2y. So I'm going to let u be the 2y part. So then u prime is derivative of 2y is 2. But since I'm involving the variable y, I need to attach a y prime. So what's in yellow is the y prime because I'm taking the derivative of some variable y. So derivative of 2 times y, or 2y, is 2 times 1, which is 2. And then the added thing is I put a y prime with it since it involves the variable y. So I'll have cosine x plus 2, and then I'll put in parentheses. So based on the chain rule, that'd be negative sine times u. So negative sine, and u is 2y, so it'll be negative sine of 2y. And then times u prime. Well, u prime is 2 and then y prime. So times 2 and then y prime. All right, so gonna rearrange it some. So I have cosine x, and I'll rearrange it. So I do 2 times 2 is 4, and then I'll have it as minus 4 sine of 2y, and then I have the y prime equal to 0. So cosine x, I would subtract cosine x from both sides since it does not involve a y prime. So I have negative 4 sine of 2y, y prime. Equal to negative cosine x. And so I want the y prime by itself. So to get it by itself, I will divide both sides by negative 4 sine of 2y. All right, so all of that cancels out. So I have y prime. And the negatives divide out, so it'll be cosine x over 4 sine of 2y. All right, and that's going to be my answer. Okay, so that one involved trig function, and I had, so again, first thing is take the derivative of both sides. When I take the derivative of sine, that's just cosine, that's a regular derivative. The 2 cosine 2y, put the 2 in front of the operator and focused on taking the derivative of cosine of 2y. Well, since I have a 2y, that 2y itself is acting in place of u. And by chain rule, it turns into negative sine of u, which is negative sine of 2y, and then times u prime. Well, u prime is the derivative of 2y. Well, derivative of 2y is 2. But since I'm taking the derivative of y, I put a y prime attached to that. So that's why it has 2y prime. All right, then from there, it's just simplifying. I combine 2 times 2 to make 4. So then I have cosine x minus 4 sine of 2y. And I put the parentheses just to be extra careful because the y prime is not part of the sine function. And then you just get y prime by itself. So I subtracted cosine x from both sides, and then I divided by the negative 4 sine of 2y. So that would be the answer, cosine x over 4 sine of 2y. All right, so that's 3 examples. I'll do a couple more examples in the next video.